Today I will discuss problem based on the linear algebra. That is, if A and T are be non-empty subsets of vector space V over the field F, prove that span of S union T is equal to span of S plus span of T. First of all, we have to know what is span of any set or subset. Span of any set is written as L of S. That is, if the set S contains the element alpha 1, or we can write x1, x2, x3 up to xn, then span of S, the set of all x such that x is equal to alpha 1 x1, alpha 2 x2 up to alpha n xn, or alpha 1 alpha 2 belongs to the field F. That all the linear combination of x1, x2 up to xn belongs to span of S. Here you have to prove what is given here. You have to say what is the given here. As it is a proof, we have to prove it. Let, or you can write given also, no problem, or given. If it is given, so you can write given. S and T are two subsets of vector space V over the field F. That means scalars whose are belongs to the field F. We have to show span of S union T is equal to span of S plus span of T. That is to show L span S union T subset of span of S plus span of T, and span of S plus span of T subset of span of S union T. So you have to see the first part. Because if A subset of B, you know, if A subset of B and B subset of A, then A is equal to B. So, first part we have to show span of S union T is equal to the subset of span of S plus span of T. A is a subset of B when if any element of A is also belongs to the B. That means you have to know it. I have to know the next page. So to prove this, let any element X belongs to span of S union T. That implies X is a linear combination. X can be expressed as the linear combination of the element of S union T. If S contains the element suppose S contains the element, you can write this is alpha 1, alpha 2 up to alpha n. And T contains the elements beta 1, beta 2 up to beta n. That's in place we can write S union T is the set of elements of alpha 1, alpha 2, beta 1, beta 2 up to beta n. So the element X which belongs to span of S union T is the linear combination of elements of S union T. So that we can write, that's why we can write X is equal to C1 alpha 1 plus C2 alpha 2 to Cn alpha n plus D1 alpha 1 beta 1 D2 beta 2 up to Dn beta n, where D1, D2, Dn and C1, C2, Cn belongs to, also we can write here, we can write Ci, Di belongs to F for all I 1, 2 up to n. Now the first set of elements belongs to the span of S and this set of element belongs to the span of T. Now let alpha is equal to C1 alpha 1, C2 alpha 2 up to Cn alpha n. That is the linear combination elements of is the linear combination of the elements of S. That's why you can write alpha belongs to span of S. Similarly, if let beta is equal to alpha 1, sorry, D1 beta 1, D2 beta 2 up to Dn beta n, then beta belongs to span of T. That implies alpha plus beta belongs to span of S plus span of T. That implies you can write this alpha plus beta is nothing that is X. So X belongs to L of S plus L of T. Initially taken x belongs to L of S union T. Now we get x belongs to L of S plus L of T. That implies we can write you can write x belongs to L of S union T implies x belongs to L of S plus L of T. That's how you can write L of S union T subset of L of S plus L of T. That this is equation 1. For the part 2, we have to prove L of S plus L of T subset of L of S union T. That's we have to prove. Let x belongs to L of S plus L of T. Then we can write x is equal to y plus z for y belongs to L of S and z belongs to L of T. As y belongs to L of S, so y can be expressed as the linear combination elements of S. We can write y is equal to C1 alpha 1 C2 alpha 2 to Cn alpha n. As z belongs to L of T, that's why we can write z is equal to d1 beta 1 d2 beta 2 to dn beta n. That's why we can write y plus z is equal to C1 alpha 1 d2 alpha 2 to Cn alpha n plus d1 beta 1 d2 beta 2 up to dn beta n. So now y plus z is expressed as the linear combination of alpha 1, alpha 2 up to alpha n and beta 1, beta 2 up to beta n. That's the elements of S union. That is the elements of S union T. That's why we can write y plus z belongs to span of S union T. What is y plus z? That is x. That implies we can write x belongs to L of S union T. So it is clear that x taken as x belongs to L of s plus L of t. Now we get x belongs to this. That means we can write L of s plus L of t subset of L of s union t. If A subset of B and B subset of A, then we can write L of S plus L of T subset of A subset B, B sub A subset B and B subset A, then A is equal to B, so that L of S plus L of T is subset of this L of S union T, and initially we proved L of S union T is subset of L of S plus L of T. That's why from these two equations we get, that is equation 2 or statement, that is also called as statement 2.